Dear students, welcome to mathematics online classes. In the last session, we did problem of 219 in the exercise 2.2. Now, we will solve the remaining two problems of the exercise 2.2, NCERT exercise. Problem number 20 and 21 are remaining. These are multiple choice questions. It is given that sine of pi by 3 minus sine inverse of minus 1 by 2, which is equal to sine of, here what we need to do, sine inverse of a negative value is there. I told you, suppose we have trigonometric functions, inverse trigonometric functions with a negative value. Here I have sine inverse of minus x. Use the property sine inverse of minus x is equal to minus sine inverse of x first. Now our problem, that is sine of pi by 3 minus, I am writing it as minus sine inverse of x. Minus minus becomes plus. This is sine inverse of 1 by 2. Sine of pi by 3 as it is plus of sine inverse of 1 by 2. Sine of which angle gives you 1 by 2? That is 30 degree. 30 degree means pi by 6. Sine 30 degree is equal to 1 by 2. 30 degree means in radians pi by 6. Therefore, we have here sine inverse of 1 by 2 is equal to pi by 6. Okay. This is sine of 60 degree plus 30 degree is 90 degree. Very simple. Sine pi by 2. What is sine pi by 2? Sine 90 value, that is 1. So, question number 20, option D correct. Coming to the 21st question, that is tan inverse of root 3 minus cot inverse of minus root 3. Okay, here this negative value will make it as positive first. For that we will use the property using cot inverse of minus x is equal to, cot inverse of minus x is nothing but pi minus cot inverse of x. We have tan inverse of root 3 minus of pi minus cot inverse of root 3. You have to be careful like this. Fine. Tan inverse of root 3 we will write, that is nothing but 60 degree. Tan 60 degree is equal to root 3. Tan inverse of root 3, 60 degree means pi by 3. Minus will get multiplied with this, minus pi, minus minus becomes plus, plus cot inverse of root 3. I have pi by 3 minus pi plus of cot inverse of root 3. Cot of which angle gives you root 3? That is 30 degree. Cot 30 degree is root 3. 30 degree in radians we will write pi by 6. See, pi by 3 plus pi by 6. 60 degree plus 30 degree is 90 degree. That is nothing but pi by 2 minus pi. Yes, you cross multiply. Pi minus 2 pi by 2. Pi minus 2 pi is minus pi. So, minus pi by 2 is the answer for this given question, that is B. With this, NCERT exercise 2.2 completed. But from the chapter inverse trigonometric point of view, the miscellaneous examples and the miscellaneous exercise is also very much important. Many times in the annual examinations, those questions are asked from the miscellaneous part. Hence, we will solve the questions from miscellaneous also here. Miscellaneous examples, that is example number 9. It says, find the value of example 9. This is miscellaneous examples. Example 9 is find the value of sine inverse of sine 3 pi by 5. Sine inverse of sine 3 pi by 5. See, while cancelling this sine and sine inverse, we have to go with the formula first. What is that formula? We know sine inverse of sine theta is equal to theta only when we have theta belongs to the that minus pi by 2 to plus pi by 2, that is principal value branch. Okay, here is this lies in the interval minus 90 to plus 90, we will check it. 3 pi by 5 is equal to 3 into pi means 180 degree. 180 degree by 5. 5 ones are 5 threes are 15, 3 remains 30 means 6. 36 it is 3 into 36. 1 3 3 is 9, 108. Okay, 108 it is. More than 90 it is going. More than 90 means it is not lying in the interval minus 90 to plus 90. So we should not cancel here sine inverse and sine. Sine inverse sine 3 pi by 5 is equal to, we should not cancel it directly. So then what to do? We need to simplify it. How? Sine inverse of sine of this 3 pi by 5 is there now. I will write it as pi minus of 2 pi by 5. Pi minus of 2 pi by 5, if you cross multiply, again it becomes 3 pi by 5 only. Fine, correct. We have sine inverse of pi minus 2 pi by 5. Pi minus 2 pi by 5 means it comes to the second quadrant. In second quadrant, sine is positive. Put positive sign here. No need to change the trigonometric function. Trigonometric function will be sine only again, because here 180, even number of 90s are there. Sine of 2 pi by 5. Okay, we have sine inverse of sine 2 pi by 5. Now you check, is this condition valid or not here? What is that? Sine inverse of sine theta is equal to theta if theta belongs to the interval, closed interval minus 90 to plus 90. 2 pi by 5. Pi by 5 means I got that 36. 2 into 36. 72. Yes, 72 lies in the interval minus 90 to plus 90. Hence we can cancel this sine and sine inverse. Okay. Answer is 2 pi by 5. Value of sine inverse of sine 3 pi by 5 is 2 pi by 5. Now we will go to the next example, that is example number 10. That is miscellaneous example. Miscellaneous example 10 says, show that sine inverse of 3 by 5, show that sine inverse of 3 by 5 minus sine inverse of 8 by 17 is equal to cos inverse of 84 by 85. This example we are going to solve. See, to solve this method, total I will say 2 methods for you. You follow the method which you feel easy. First method, see here a cos inverse is there and a negative is there. Cos inverse and a negative is there. What you do, you use the formula cos of a minus b is equal to cos of a minus b is equal to cos inverse is there, hence cos here minus is there means minus, plus is there means plus. This type of problems if appears, you can go like this. Cos of a minus b is equal to cos of a minus b is equal to, we have studied the formula in the first PU, that is cos a into cos b plus sin a into sin b. Now what we will do, we will substitute a is equal to sin inverse of 3 by 5 and b is equal to sin inverse of 8 by 17. We need to find out all these values. How? Here what you do, you substitute, put A is equal to sine inverse of 3 by 5. This is nothing but sine A is equal to 3 by 5. Okay, we got sine A value. Next what I need? I need cos A value also. For that, cos A is equal to, what is the formula for cos A? We know that sin square A plus cos square A is equal to 1. That is sin square A plus cos square A is equal to 1. I want cos A here. So cos square A is equal to 1 minus of sin square A. Then cos A is equal to square root of 1 minus sin square A. I am using this formula. Cos A is equal to square root of 1 minus sin square A. Square root of 1 minus. What is sin A here? Sin A is nothing but 3 by 5. 3 by 5 whole square. So square root of 1 minus 9 by 25. That is square root of cross multiplying 25 minus 9, 16. 16 by 25. This can be written as 4 by 5. What is this? This is cos A is equal to. Okay. We got cos A and sin A. Both are there. Now to get this cos B and sin B, what you substitute? This B is equal to this one you substitute. Put A is equal to this got over, and B is equal to sin inverse of 8 by 17. This implies sin B is equal to 8 by 17. Sin B value I got. Now only the trigonometric function which is left here is a cos B. Okay, use the formula. Cos B is equal to square root of 1 minus sin square B. Square root of 1 minus of sin B value is 8 by 17 whole square into square root of 1 minus of, this is 8 square, 64 by 17 square, 289. If you cross multiply, square root of 289 minus 64 divided by 289, this is 225. Square root of 225 by 289. How much is this? This is 225, 15, and this is 17. I got cos B is equal to 15 by 17. Okay. Now coming to the problem here. What is that? We are substituting in the formula. We know cos of A minus B is equal to, I am rewriting that once again, cos A into cos B plus sin A into sin B. This is the first year formula we have studied. Okay. Cos of, what is A? A means sin inverse of 3 by 5 minus of B means sin inverse of 8 by 17, which is equal to cos A value 4 by 5, substitute that, into cos B value 15 by 17, 15 by 17 plus of sin A value 3 by 5 into sin B value 8 by 17. Okay. Cos of sin inverse of 3 by 5 minus sin inverse of 8 by 17, which is equal to 4 into 15 is 60 by 5 into 17 is 85 plus of 3 into 8, 24 divided by 85. Okay. This can be written as cos of sin inverse of 3 by 5 minus sin inverse of 8 by 17, which is equal to LCM is 64 and numerator is 60 plus 24 is nothing but 84. Okay, here cos is there. Taking that to the right hand side, I have sin inverse of 3 by 5 minus sin inverse of 8 by 17, which is equal to cos inverse of 84 by 85. Yes, we have proved that. We got that. Okay, this is one method of solving this kind of equations. Sin inverse or cos inverse is involved means this is how we should proceed. One way. Let me solve the same problem in another way. You take which method is easy for you. There is no restriction like we should follow only this method, that method. No, it is not like that. Or left hand side, sine inverse of, here we are proving that, show that sine inverse of 3 by 5 minus sine inverse of 8 by 17, which is equal to cos inverse of 84 by 85 is that. Okay, here sine inverse of 3 by 5 is equal to, here what we should do, we will use the formula of tan inverse of x minus tan inverse of y formula here. Tan inverse of x minus tan inverse of y is tan inverse of x minus y by 1 plus x into y. That formula we will be using. So this sine inverse of 3 by 5 we should write tan inverse of. And this sine inverse of 8 by 17 also we should write in terms of tan inverse again. So that we can use the formula for tan inverse minus tan inverse. Okay. Sine inverse of 3 by 5 is equal to theta I will take. This is nothing but sine theta is equal to 3 by 5. Sine theta you write using a right angle triangle. Here if I consider theta, this let me name the vertices A, B, C. Sine theta is equal to 3 by 5 means it is the ratio of opposite side and hypotenuse. Using Pythagoras theorem, what will be the adjacent side? Adjacent side is 4. Okay, from this table, what is tan theta? Tan theta is 3 by 4. Tan theta is the ratio of opposite side to adjacent side. Then what is theta is equal to? This implies theta is equal to tan inverse of 3 by 4. You see, theta is equal to sine inverse of 3 by 5 I have taken. And here we are getting theta is equal to tan inverse of 3 by 4. Means in place of sine inverse of 3 by 5, I can write tan inverse of 3 by 4. Now same way you convert the sine inverse of 8 by 17 also in terms of tan inverse. Again you take sine inverse of 8 by 17 is equal to pi. This is nothing but sin pi is equal to 8 by 17. Sin pi is equal to 8 by 17 I got. Write it in a right angle triangle. This is pi. Again A, B and C. Sin is the ratio of opposite and hypotenuse. That is 8 by 17. According to the Pythagoras theorem, you apply this hypotenuse square is equal to sum of squares of other two sides. This AB will be 5. Okay. 8 by 17, 5. Is it 5? No, it is not 5. It is 15. How? AC square is equal to here AB square plus BC square. I have AB square is equal to AC square minus BC square. AC square 17 square minus 8 square. 289 minus 64 is 225. AB square is equal to 225. I have AB is equal to 15. Okay, that is 15. Now what will be the tan phi? Tan phi is equal to, it is ratio of opposite side and adjacent side, 8 by 15. Then pi is equal to tan inverse of 8 by 15. Means we are converting this sine inverse and this sine inverse in terms of tan inverse. Take LHS. LHS is equal to sine inverse of 3 by 5 minus sine inverse of 8 by 17. This can be written as sine inverse of 3 by 5 is nothing but tan inverse of 3 by 4. Tan inverse of 3 by 4 minus of sine inverse of 8 by 17 pi. Here also pi is equal to, this is tan inverse of 8 by 15 I got. Now it came to the form tan inverse of x minus tan inverse of y. So you use the formula using tan inverse of x minus tan inverse of y. This is nothing but tan inverse of x minus y plus 1 plus xy. We have here tan inverse of 3 by 4 minus 8 by 15 divided by 1 plus 3 by 4 into 8 by 15. tan inverse of, now cross multiplying, 15 into 3, 45 minus of 4 into 8, 32 divided by, next again here 15 into 4, that is 16, 60 plus 8 into 3 is 24 divided by, here also that divided by 60 will be there, here also divided by 60 will be there, 15 into 4, both are getting cancelled, I am leaving it here. Okay, we have tan inverse of 45 minus 32 is a 13 by 84. This is what we got, that is tan inverse of 13 by 4 as the RHS. But is the RHS here? They have given you that this should be cos inverse of 84 by 85. Whatever how you have converted in the previous case, same way you convert to cos now. For that conversion, what you do? Let tan inverse of 13 by 84 is equal to, you take theta. Then this is tan theta is equal to 13 by 84. Write it in a right angle triangle. This is theta. Tan is the ratio of opposite side and adjacent side. 13 by 84 we will get. 13 and 84, according to the Pythagoras theorem, you apply it. Hypotenuse will be 85. Pythagoras theorem. If you take this as P, Q and R, according to the Pythagoras theorem, PR square is equal to PQ square plus QR square, where we know PQ and QR. Apply and take the square root of that, we will get it as 85. Now, tan theta is equal to 13 by 84 is there. Theta is equal to tan inverse of 13 by 84. That is fine. What we want now? We want the value of cos here actually. So, what is cos theta is equal to? Cos theta is the ratio of sides, adjacent sides and hypotenuse. Adjacent sides and hypotenuse, that is 84 by 85. Then theta is equal to cot inverse of 84 by 85. Okay, now I can substitute that as cos inverse of 84 by 85. This is the RHS. Here it takes the simple steps here, but that calculation behind is somewhat huge. We can follow the method you feel easy. First method is this, using that cos formula, and the second method is this, using tan inverse of x formulas. Thank you.